Good morning, professors, and welcome to an exciting new experiment conducted in collaboration with the Wacebo ScienceBus. In today's scientific experience, we will explore how to effectively utilize a digital multimeter to accurately measure the equivalent resistance of a circuit that contains resistors connected in series. The experiment is suitable for high school students, and in order to successfully conduct it, we will require the electricity kit. Let's begin by carefully inserting the boxes into the circuit board. After that, we proceed to establish a connection in order to achieve the configuration of a circuit that contains resistors arranged in series. This is the ultimate configuration where we possess a 100 ohm resistor along with a 220 ohm resistor, both connected in a series arrangement. We take the black cable, carefully insert one end into the 2-hole box, and the other end will be inserted into the COM port of the multimeter. Let's proceed by taking the red cable. We will carefully insert one end into the 2-hole box. Then take the red cable again, and one end will be inserted into the 2-hole box, while the other end will be connected to the volt-ohm port of the multimeter. Let's proceed by establishing the appropriate measurement range. Given that the combined resistance of the two resistors exceeds 200 ohms, we will adjust the range setting to 2000 ohms. Let's power on the multimeter and carefully observe the equivalent resistance value of the circuit displayed on the screen. Let's then compare this observed value with the precise one obtained from the series resistance formula. When resistors are connected in a series configuration, the electrical current that flows through them remains consistent, while the potential difference across each individual resistor varies unless they possess identical resistance values. When multiple resistors are interconnected in a series configuration, the equivalent resistance of the entire circuit is determined by the summation of the individual resistances. In this particular instance, the equivalent resistance will be the sum of 100 ohms and 220 ohms, culminating in a total of 320 ohms. Let's power down the multimeter and modify the configuration. We shall incorporate an additional resistor which has a resistance of 100 ohms. Power up the multimeter and take note of the equivalent resistance value displayed on the screen. In this specific configuration, we presently have 3 resistors interconnected in a series arrangement, leading to an equivalent resistance of 420 ohms. Let's proceed by replacing the 100 ohm resistor with a 470 ohm resistor. The scale limit, which is configured to 2000 ohms, remains appropriate. Let's carefully observe the equivalent resistance value as displayed on the multimeter screen and compare it with the value obtained from the theoretical formula. The experiment can undoubtedly be conducted once more with various resistors, ensuring that the appropriate range is configured each time. This experience consequently facilitated the precise measurement of the equivalent resistance of a circuit with all resistors interconnected in series utilizing the multimeter. Professors, thank you. See you at the next experiment. Goodbye.